Hello friends, myself Rajendra Mahajan presenting my video on solution of differential equation by Laplace transform technique. Let us solve the problem. d2x by dt square plus x is equal to cos 2t. Conditions x of 0 is equal to 3 and second x dash of 0 is equal to 1. Again, this is initial value problem which we have to solve by Laplace transform. And therefore the given differential equation is d2x by dt square plus x is equal to cos 2t. For better understanding, watch the video up to end. Therefore, first step is the Laplace on both sides. Therefore, Laplace of left hand side is Laplace of first term d2x by dt square, second order derivative, Laplace of x, and that is equal to Laplace of cos 2t. Then applying the standard result, Laplace of second order derivative is s square x bar of s, here function is x of t, minus s x of 0 minus x dash of 0 plus Laplace of x is x bar of s, and that is equal to Laplace of cos 2t is s upon s square plus a square. A is here 2, therefore 2 square, it is 4. Collecting the terms of x bar of s, we get s square plus 1 into x bar of s is equal to s upon s square plus 4. Value of x of 0 is 3 minus 3s, transferring to right hand side it becomes 3s. X dash of 0 is 1 minus 1, if we transfer it becomes plus 1. Then dividing by s square plus 1, therefore we get x bar of s upon s square plus 4, and divided by s square plus 1, it becomes 1 upon s square plus 1. Then this 3s divided by s square plus 1, we get 3 times s upon s square plus 1 and 1 upon s square plus 1. We call this as equation 1. The next step is the inverse on both sides. Therefore, inverse Laplace of left hand side, inverse Laplace of right hand side term. Again, inverse of first term, inverse of second, inverse of third, and therefore it is inverse Laplace of s divided by s square plus 4 multiplied by 1 upon s square plus 1 plus 3 into inverse Laplace of s upon s square plus 1 and plus inverse Laplace of 1 upon s square plus 1. We call this equation 2. Inverse of s upon s square plus 1, standard result, it is cos t. Inverse of 1 upon s square plus 1, again standard result, it is sin t. And inverse of the first term we have to obtain by a convolution, as here it is a product of two terms. And therefore, to find this inverse, we know that inverse Laplace of the first term s upon s square plus 2 square, that is 4, as cos of 2t inverse of second term 1 upon s square plus 1 as sin t, both containing one term of t, therefore any one is we call as f of t and remaining as g of t. Here first term I will call as f of t and the second term as g of t. See, then we obtain the inverse by convolution theorem. Then applying convolution method to find the inverse of this product, it is equal to integration from 0 to t f of u into g of t minus u, and therefore replacing t by u in f of t, and in g of t replace it by t minus u. We get it is integration from 0 to t. F of u is cos of 2u. In g of t replacing t by t minus u, we get sine of t minus u and its integration with respect to u. Here it is a product of sine cos term. Therefore, to apply that defactorization, we have to multiply it by 2 and divide by 2 as I have done in my previous example. It is 1 by 2 integration from 0 to t sin a cos b 2 times. It is sin a plus b plus sin a minus b. It is sine of t. 2u minus u remains u, and this one is sine of t minus u minus 2u, it is minus 3u. Then integrating these two terms of sine, its integration is minus cos t plus u divided by coefficient of u 1. Integration of this minus cos of t minus 3u divided by minus 3. Limit from 0 to t. This become minus minus plus. Therefore, substituting the upper limit for t u as t, it become cos of t minus 3t. T minus 3t, nothing but cos of minus 2t by 3. This one with minus sign. U as t, t plus t, we get cos 2t for upper limit. Then minus lower limit, u as 0, therefore this become minus cos t, and minus minus plus, u as 0, therefore it is cos t by 3. Therefore it is 1 by 2. Cos minus theta is cos theta, and therefore this is cos 2t by 3 minus cos 2t. This become minus minus plus cos t, and this one is minus cos t by 3. It is 1 by 2. 1 by 3 minus 1, and here also we can take common 1 by 3 minus 1, and plus cos t we can take common 1 minus 1 by 3. It is equal to 1 by 2 cos 2t uh, 1 minus 3, that is minus 2 by 3 into 1 minus 3, that is minus, and this is 3 minus 1, that is 2 by 3 into cos t, equation 3. Multiplying by 2 inside, this 2 to get cancelled, it is 1 by 3 cos t, and this one is minus, and instead of calling this as 3, we call this as equation 3. And then substituting this in equation 2, we get inverse of x bar of s as x of t. Inverse of first term is 1 by 3 cos t minus 1 by 3 cos of 2t. Inverse of s upon s square plus 1 is cos t, and inverse of 1 upon s square plus 1 is sin t. Therefore, there are two terms of cos t. It is 1 by 3 plus 3 times cos t minus 1 by 3 cos of 2t and plus sin t. 9 plus 1, we get 10 by 3 cos t minus 1 by 3 cos 2t and plus sin t. Is the required solution of the given differential equation obtained by Laplace transform technique. One more I will discuss in my next video. Please like my video, share it, as well as subscribe to my channel if you are not subscribed yet. And to receive the notification for my all new videos, please press the bell icon. Thank you. Thanks for watching.